Hi everyone! In the previous videos we saw how we can update the network and also do the entire backpropagation algorithm. But now I will do a little summary to summarize everything that we have seen and all the formulas we will be using when we implement the network in Java. So the first thing is the feedforward. The feedforward, as we have seen, goes in this direction, and with some neurons values from a specific layer, we'll calculate the next layer neuron values. Okay, so to apply the feedforward algorithm, we'll use two functions. With the first, we'll calculate from the previous layer out neurons, we'll calculate the next layer net neurons. And with these net neurons calculated, we will apply the activation function to calculate the out values of the neurons. Okay, so for example, in this neuron, in this network, to calculate this value, because this value and this value will be set by the programmer depending on the data we want to train our network. So these values will be set previously. So to calculate the next layer values, we will just multiply the value of this neuron multiplied by the connection that connects the neuron and the neuron we want to update, and also this value multiplied by this weight, and we sum both results, and then we add the bias that connects the bias neuron to the value we want to calculate. So we'll add this value. So as you will see in the formula, we are multiplying this and doing the sum of all the results, and then we finally add the bias value. And when we calculate this value and this value with the same way, we will apply the activation function that is this. And in this case, I put a logistic that is the main function we will be using. So we will apply it and calculate the out value of them. And with these steps, we can calculate all the values, because we will have these values and we can calculate the next layer values and so on. And finally, with the output layer out values, we will be able to calculate the error the network has done and we want to decrease with the error function, that in this case I use the mean square error, that we do the difference between the desired value we want the network to have minus the value the actual output neuron has, and divided by the number of output neurons. So then, when we do the feedforward, we do the backpropagation in the opposite direction, because we will be using the chain rule. So we defined here the error signal that is in charge to simplify and store the previous chain rules calculated for the neurons. So depending on the actual layer, the error signal will be calculated differently. If we are in the last layer, that is this layer, we will just do the derivative of the error, okay, and then the derivative of the activation function. As you are seeing here, this is the derivative of the activation function, that is in this case the logistic, and here the MSE derivative is the derivative of the error, that is this, okay. However, if we are in other layer, for example, we are in the second layer, to calculate the error signal of these neurons, we'll use the signal of the other layers we have calculated the error signal. So with this error signal we calculated, okay, I put here 1 and 2. We'll calculate the error signal of these neurons. And the way is to calculate it, we'll just if we want to calculate this neuron, for example, that is this, we will multiply the error signal of this neuron multiplied by this weight and add the error signal of this neuron multiplied by this error signal and multiplied by this weight. And with this result, we'll apply the activation function, that is this, the derivative of the activation function. And we will store this value as the error signal of this layer neuron. And then finally, to calculate the final derivative of the error with respect to each weight is just as simply as multiplying. For example, if we want to update this weight, we'll multiply the error signal of this neuron multiplied by the out value of this neuron. If we want, for example, to calculate the derivative with respect to this weight, it will be to multiply the error signal of this neuron multiplied by the out value of this neuron. Okay, and with this we can apply this to every weight and update and calculate its derivative. And to the derivative with respect to the bias is as simply as assigning it the error signal. Okay, so for example, if we want to update this bias, we just use this error signal and update, and it will be the derivative. And with this, we have seen the both important algorithms, and we will start in the next videos with the gradient descent that will be in charge of updating the weights and bias to decrease the error. That is the last part of the main algorithm. And see you in the next video.